In this video we're going to see that for each of the trigonometric functions, the sine, the cosine and the tan, we're going to have two different angles that will give us the same value for each of the functions. So this is best seen by this graphical example here. So let's start off by looking at the sine function. So as we move this round about, now I've added a few extra lines in here, but ostensibly it's the same as we've seen before. We have this little red dot which moves round about the circle and it would generate this sine function. Now I've taken off the height here and I've just drawn the straight line across. Now the straight line here is going to cut the sine function at two different points. So it means that if I was to find the sine of this angle here, I would get this height, and if I was to find the sine of this angle here, I would get this very same height. So it means that I can put in two different angles into my calculator, and whenever I find the sine of them, I'm going to get the same value. Now you can see here from the symmetry of the sine function, the sine function repeats every 360 degrees. So this point here is going to be 180 degrees. So if, say for example, this angle was 30 degrees, so this is a little angle here was 30 degrees, then we could work out the sine of the 30 degrees and it would be this height here. But it would also be the same as 180 minus the 30 degrees. So this point here is 180. So let's have a look and see if we can get the 30 degrees. Now I've put the two angles actually up here. So these two angles here represent the angles at the green line here and the green line here. So I've actually put them into degrees. So the first one here we could say is, say this is 30 degrees. I've not got it quite right, it's actually 30.9. So it's close enough. You can see it's approximately, say, 30 degrees. Then it means that the other angle here is going to be 180 minus the 30 degrees, which would be 150 degrees. Now the same thing's going to occur whenever the sine function is negative. But whenever it's negative, it means that this line here is actually going to be drawn along this here, and it's going to cut at, say, this point and this point. So this means that, for example, if we were to look at the third and fourth quadrants, which this quadrant and this quadrant here, the values are going to be negative for the sine. So if we were to say take an angle of, say, 210 degrees, well, 210 degrees would be 30 more than 180, but this is going to be symmetrical, so it means it's going to be 30 degrees less than the 360. So it means that if I was to work out the sine of 210 degrees, it would be the same as the sine of 360 minus the 30, which would be 330 degrees. So all we're looking at here is the fact that we're going to have two angles for each value, whether the sine is positive or the sine is negative. Now it's best seen by actually working through a few examples, and we'll do that in the next video, but we'll go ahead and we'll see what happens with the cosine and what happens with the tangent. So let's see what happens whenever the cosine is a positive value. We can see that it's positive from 0 to 90 here, which is this first quadrant, and it's also going to be positive from the 270 to 360, which is this fourth quadrant here. So the cosine is going to be positive in this quadrant and in this quadrant here. So if I was to take, for example, an angle of, say, 30 degrees, so an angle of, say, 30 degrees, something round about here, then this angle here is going to be the same as taking the cosine of the angle in 360 minus the 30 degrees, which would be 330 degrees in the fourth quadrant. So that would be the same as this angle round here. So again, in this graph here, if we had 30 degrees here, then that 30 degrees would be the same if we take this point here and map it across to here. It would be the same as the 360 minus the 30, which again would be the 330 degrees. Now we can see here as well that the cosine is going to be negative in quadrants 2 and quadrant 3. So it's going to be negative in this quadrant here and this quadrant here. So let's say for example we had 120 degrees. So 120 degrees is just 30 degrees past this 90 here. So we know that the cosine is negative in this second quadrant, which is here, which if this is 90, it would be 30 degrees past us, so it would be somewhere around about here. But that means then that this point here would be the same as this point, say over here somewhere. But this point over here is going to be 270 minus the 30 degrees. So that would be the same as 240 degrees. So it means that the cosine of 120 degrees would be the same as the cosine of 240 degrees. So let's look what happens with the tan function. Let's say the value of your tan is a positive value. So the tan is going to be positive in the first quadrant here. So that's 0 to 90 degrees. It's also going to be positive in the third quadrant. So this here is 180 to 270 degrees. So it's positive in this quadrant here and also in this quadrant here. So let's say for example we were looking at the tan of 45 degrees. So the 45 degrees is going to be somewhere along here and it's going to cut this curve here at some point. But if it cuts it at this point here, if we draw a line across, it's going to cut it at a point along here as well. So it means that if we were to look at the tan of 45 degrees, in order to get the second value, we would be taking this point here, which is the 180 degrees, and we would be adding on the 45 to get to this point here. So it means that the tan of 45 degrees would be the same as the tan of 180 plus 45, which would be the tan of 225 degrees. So finally let's look at what happens whenever the tan is a negative value. So the tan is going to be negative in this quadrant here, which is the quadrant 2, so that's 90 to 180 degrees, which is this one, and it's also going to be negative in the fourth quadrant, which is the 270 to 360 degrees, so that's this quadrant here. So the tan is negative in this quadrant and it's negative in this quadrant. So let's look at taking the tan of say 120 degrees. So 120 degrees is in the second quadrant, so that's 90, 120 is going to be something like this here. So it's going to be a negative value, so it's in this quadrant here, which is the second quadrant from 90 to 180 degrees. So that's going to be 90 degrees down here plus the 30 degrees it takes us to 120, so we're going to have somewhere round about here. So let's say it's this point here. We know that we're also, if we draw the straight line across, it's going to occur at this point here. But this point here is nothing other than the 270 degrees plus the value over 30 degrees, which is 300 degrees. So it means that if we were to look at the tan of 120 degrees, that would be the same as the tan of 300 degrees. So now, if I was to be honest, whenever I'm teaching this stuff, this tends to be something that students get confused on. Usually when you see it taught, it's taught in terms of we put a number into a calculator and we forget about the negative sign, and when we forget about the negative sign, we either add 180 on or take it away from 180 or take it away from 360, and it's very easy to get confused, especially if you get into an exam situation. So I always think it's best if you can understand the graphs, and then you can define from your all sinners take care and also the graph exactly where the second angle is going to be. And as well, rather than doing it here in terms of a graphical calculator, which gives you a bit of an intuition, it's best to sit down and go through examples, and that's what we're going to be going to do in one of the example videos. So don't get too worried if you found this a bit confusing, because this is probably one of the most awkward parts of the trig course that we have here in this whole course, and it's best understood by the examples which we're going to get on to next.